Question 14. An aeroplane is flying horizontally. Believe it or not, that's really important. Directly towards Brisbane at an altitude of 4.57 kilometres. Cool. I think my diagram represents that. Altitude is perpendicular. There's Brisbane, labelled B, aeroplane labelled A, 4.57. So that's what you should start with. At one point, the pilot sees the city lights of Brisbane at an angle of depression of 3.46. Okay, let's get that in. Angle of depression. So from the horizontal, the pilot looks down, and it's not to scale, sees Brisbane. So that's what the pilot, that's what she sees. She's looking down, and she sees Brisbane. Now, we have to remember that the plane will keep flying. So she's looked down, angle of depression, which lives in here. Angle of depression. Right? Cool. Now, 15 minutes later, now the plane is flying towards Brisbane. So 15 minutes later, the plane is going to be in a different position. Let's put the plane here. That's after 15 minutes. So that's the distance. AC is the distance they've flown in 15 minutes. Pilot sees the city lights at an angle of depression of 4.15. So she's closer because it's a steeper angle of depression. She's looking down more. Okay, so she's by default, she's flying closer to Brisbane. So she's closer. So let's have a look at that. So we draw that line in. Cool. That's got an angle of depression of 4.15 from the horizontal down. Cool. Down. That's my diagram. Find the speed of the plane. Speed. Okay. Speed is distance by time. We need to know that. Right. Sorry. Distance on time. Right. How far you've travelled, how long it took you to travel it. So it's up to us now how we want to move around and do this question. We actually need to find the length of A to C. So it's up to you what you do next. So a lot of people will go, right, I'm going to complete the triangle, and I'll put this in, and that's going to be the same distance, 4.57. Other students will use the Z rule, and they'll bring this down and say, well, that's 3.46 there, and that is 4.15. Cool. Either way is going to work. Either way will work. We've just got to remember, I've got to find this distance A to C. So my logic in this is I've got two triangles. I'm going to do two separate things here. First thing I'm going to do, just trying to find an appropriate color, I'm going to find the distance using the big triangle from there to there. I call that D, if you like. So my logic is this. In the big right angle triangle, I can say that tan of the angle 3.46 will equal opposite on adjacent. So AD, the total distance the plane was horizontally from Brisbane when the pilot first looked down was 75.6 kilometers. 75.6 kilometers. Cool, that's AD. Now, second part, I'm going to use the smaller triangle. Same logic, tan 4.15 is going to equal on CD. Therefore, CD will equal 62.98. Well, that's close enough to 63 kilometers. So there's the two necessary distances. I've found A to D, and I've also found C to D. So AC, which is what I'm chasing, is the difference. This is how far this plane has traveled in 15 minutes. Okay, so that's the first thing I'm going to worry about. That's 12.6 kilometers. Now, that's in 15 minutes, quarter of an hour. So therefore, the speed of the plane, it's traveled 12.6 kilometers in 15 minutes. So there's 4 lots of them in an hour. So the plane will travel, according to my calculations, 50.4 kilometers in 1 hour. Ergo, the speed of the plane, not traveling very fast, is there. So this was another one of those compound triangle questions. We had to look at what we had, take one away from the other, etc., etc., etc. Okay, so that was quite a tricky one. Hope that helps.